Question 1. Expand x minus 3 times x minus 4. I like to follow these steps. Split the first bracket, expand each section, then collect like terms. So x minus 3 in that first bracket, each of those parts have to be multiplying through the second bracket. So I like to split that up and say, okay, I like to write it out carefully. X outside of x minus 4, minus 3 outside of x minus 4. That way each of those first bracket terms gets to multiply through the second bracket, and I do it nice and systematically, all written down, and make it easier for my brain to just do one step at a time. X times x makes x squared. X times minus 4 makes minus 4x. Then we move to the second part. Minus 3 times x makes minus 3x. And careful here, this is where a lot of students go a little bit too fast. This is minus 3 times minus 4, which makes a plus 12. Somehow, magically, we often forget about that minus on the front number when we multiply it by the second number in the bracket, mysteriously. Happens to a lot of students. So here we have some like terms that we can collect. You notice there's two x terms there that can join in to be one here. Only in the middle there, we don't have to mix up the x squared as well. But minus 4x minus another 3x makes minus 7x. So we can just simplify that a little bit, and we get x squared minus 7x plus 12 for our final answer. Question 2. Find the acute angle theta correct to the nearest degree if cos theta equals 0.6. For this, we're finding an angle, and we must press shift at some stage when we're finding an angle, otherwise we'll get a very strange answer. We'll press shift cos 0.6 equals into our calculator, and we're asked to get it to the nearest degree there. So when we press that in, we'll get theta equals 53 degrees, and you'll be encouraged there to round off the degree carefully. Question 3. Simplify minus 5a times 4ab. We multiply the numbers normally and list the letters beside each other. And whenever we have one letter times another letter of the same type, or a times a, we'll make a squared. So we'll watch out for that. So the numbers wise, we have minus 5 times 4, a minus times a plus makes a minus. 5 times 4 is 20. And we have an a times an a, so I'm glad we were warned about that. A times a makes a squared, and we've just got a b that gets listed beside it. So final answer there, minus 20 a squared b. Question 4. Find the median of this set of numbers. We have 8, 12, 13, 15, 17, 18, 20 and 22. The median for an even number of values, and we have 2, 4, 6, 8 values here. The median for an even number of values is the average of the two middle values once the data is placed in order. This data is already in order, so we should look for two middle values. So I think you can see in the middle there, we can have 15 and 17 as the ones we're focusing on, and we need to take the average of those. So the average of two numbers is those two numbers added together divided by 2. So we'll add those two together and divide by 2. I think we get 32 over 2, which makes 16. Question 5. Solve p over 2 plus 4 equals 12. To solve an equation, we do the opposite to both sides here. So the opposite of a plus 4 is a minus 4. So we'll minus 4 both sides. We're aiming to get the letter on its own, of course. So if we minus 4 here, the plus 4 and the minus 4 will cancel each other out on the left-hand side, leaving us with p over 2. And on the right-hand side, we just do that calculation. 12 minus 4 is 8. So we continue with our quest for getting the letter on its own. Let's move that 2. The 2 at the moment is dividing. The bottom of a fraction is considered to be dividing into the top. So the opposite of dividing by 2 is multiplying by 2, which we'll do to both sides. And so that'll leave p on its own on the left-hand side, and 8 times 2 is 16 on the right-hand side. So just a two-step equation there. Question 6. Find the value of g in the diagram below. So the 7g and the 283 certainly makes up one full revolution. So adjacent angles that make up one revolution, they add up to 360 degrees. And so we can make a little equation out of this. The 7g equals 360 degrees minus 283 degrees. You can kind of see that the full 360, if we take away the 283, we'll get that 7g section left, won't we? So just to simplify that, we'll get 7g equals 77 when we subtract that right-hand side there. The 7 is multiplying by the g, so to get the g on its own, to solve our little equation we've created here, we'll divide by 7 both sides, leaving us with g on the left, and 77 divided by 7 is 11. So working backwards there, following that rule that they should add up to 360 degrees for one revolution, we end up with g equals 11 degrees. Question 7. Simplify, writing your answer as a whole number, 5c to the 0. There's a rule that says any item that has a power of 0 equals 1. So carefully there, c has a power of 0, but the 5 doesn't. The 5 and the c aren't in brackets, so the 0 doesn't affect the 5. So we have 5 lots of c to the 0, or 5 lots of something that's considered to be 1. So we just get an answer of 5 there. Question 8. Which of the following lines is parallel to y equals 5x plus 3? Now y equals 5x plus 3 is in what we call the gradient y-intercept form. So parallel lines that's asked in the question, they have the same gradient. So our gradient from y equals 5x plus 3 can be read off whatever number is in front of the x once it's in that proper format there. So we can say that in our question, m is the gradient and the gradient is 5 from our question expression there. Now let's have a look at the options here and see which of these lines have a gradient of 5. And thankfully the last one there is in the same format, and we can find its gradient happens to be 5 straight away. Wouldn't have been an easy question otherwise. We would have had to rearrange some of the other ones to double check. But seeing there's one there that has a gradient of 5, we can highlight that as the correct answer. And correct answer there is D, y equals 5x minus 8. Question 9. Find the area of this figure. It's a parallelogram. Okay, the steps for formula type things. We want to look to write a formula on the first line, substitute all the numbers in that we've got from the question on the second line, and calculate our answer, and we'll just double check our units at the end. So the formula for this is the area of a parallelogram. It's got a formula of the area equals the base times the perpendicular height. So we'll look and we'll see that the base looks like it's 16 meters and the perpendicular height looks like it's 8 meters. So area equals base times height, and here we've got 16 where we'll put straight under the B for base, and we've got an 8 that we'll put straight under the H for perpendicular height, and we'll multiply that out. So we get 128. Now we've quoted it as meters squared because area it's a square units type scenario. And when we're multiplying, if we wrote out 16 meters and 8 meters and had a multiply between them, it's almost like the m times the m makes an m squared, just like it does in algebra. So that's a good double reminder as well. But so we need meters squared for area. Question 10. Find the value of the shorter side, D, below, giving your answer correct to 2 decimal places. Finding a shorter side, this is the way to set up the Pythagoras question here. The letter squared should equal the bigger side squared minus the smaller side squared. We use a minus between the squared bits in Pythagoras when we're finding a shorter side. Alright, so the letter we've got is D, so D squared equals, now the bigger number is 32.85, so we'll put that next, and it's got a squared there. And we'll minus the smaller side, which in this case is 21.9. So we'll set it up nicely there, set out clearly. Then we can just process it. D squared is that big number minus that big number on our calculator. And we'll do that subtraction and get a final answer for the number section. And D squared equals 599-ish. Now we want D on its own, so we'll need to do the opposite of squaring, which is square rooting, and we'll need to do it to both sides. On the left-hand side, square rooting will cancel out the squared and leave us with D, which is what we want, but we'll need to process in the calculator square root of 599 and change. So carefully in the calculator, we'll end up with a D value of 24.48. Now we were expecting a number that's smaller than 32.85 as a bit of a double check. And we will need to round off carefully to 2 decimal places because that's required of us in the question as well. That's finding a shorter side using Pythagoras. We're squaring everything and we're setting it up with a minus in between. Big number squared minus small number squared.